Hello, welcome to Learning Box. Today's discussing topic is logistic regression. Understanding logistic regression. Logistic regression estimates the probability of an event occurring, such as voted or didn't vote, based on a given data set of independent variables. Logistic regression is a powerful statistical technique used in various fields, from healthcare to marketing, for making predictions and classifying data. Despite its name, it's not used for regression tasks, but rather for classification. How does it work? Its core. Logistic regression predicts the probability that an instance belongs to a particular class. Unlike linear regression, which predicts continuous values, logistic regression outputs probabilities. These probabilities are then transformed using the logistic function to ensure they fall between 0 and 1. Key concepts. Binary outcome. Logistic regression is used when the dependent variable is categorical with two possible outcomes, often labeled as 0 and 1. Logistic function. The logistic function, also known as the surd function, transforms the output of linear regression into a probability between 0 and 1. Decision boundary. Logistic regression calculates a decision boundary that separates the classes. Instances falling above the boundary are classified as one class, while those below are classified as the other. Types of logistic regression. There are three types of logistic regression models, which are defined based on categorical response. Binary logistic regression. In this approach, the response or dependent variable is dichotomous in nature, i.e. it has only possible outcomes, e.g. 0 or 1. Some popular examples of its use include predicting if an email is spam or not spam, or if a tumor is malignant or not malignant. Within logistic regression, this is the most commonly used approach, and more generally, one of the most common classifiers for binary classification. Multinomial logistic regression. In this type of logistic regression model, the dependent variable has three or more possible outcomes. However, these values have no specified order. For example, movie studio want to predict what genre of film a moviegoer is likely to see to market films more effectively. A multinomial logistic regression model can help the studio to determine the strength of influence a person's age, gender, and dating status may have on the type of film that they prefer. The studio can then orient an advertising campaign of a specific movie toward a group of people likely to go see it. Ordinal logistic regression. This type of logistic regression model is leveraged when the response variable has three or more possible outcomes, but in this case, values do have a defined order. Examples of ordinal responses include grading scales from A to F or rating scales from 1 to 5. Applications. Spam detection. Logistic regression can be used to classify emails as spam or not spam based on various features. Credit risk analysis. It's employed in finance to assess the risk of default by borrowers. Medical diagnosis. Logistic regression helps in predicting the likelihood of a patient having a particular disease based on symptoms and test results. Logistic regression is a fundamental tool in the data scientist's toolkit. Its simplicity, interpretability, and effectiveness make it a popular choice for binary classification tasks. By understanding the basics of logistic regression, you can leverage its power in solving real-world problems across different domains. Moving to next. Practical example in binary logistic regression. First part is installing requirements. Install requirements by using pip in CMD. Use pip install scikit-learn to install scikit-learning library. Data requirements. Topic we are going to discuss is IPL teams winning factor. There many teams participate in IPL tournament, but for our example, we are just taking two teams. They are RCB and CSK. We have data which is related to only these two teams. Say, Team 1 RCB, Team 2 CSK, year 2019, and RCB 1. Team 1 RCB, Team 2 CSK, year 2020, and RCB 1. So on. Similar, Team 1 CSK, Team 2 RCB, year 2019, and CKS 1. Team 1 CSK, Team 2 RCB, year 2020, and CKS 1. So on. Problem statement. 1. Team 1 indicates ground. 2. Predict the home ground winning factor. Again, repeating problem statement. 1. Team 1 indicates home ground. 2. Predict the home ground winning factor. Hope you understand the data. Data processing. The conversion of raw data into meaningful information. It is also right to say that data processing becomes the process of converting information into data and also vice versa. Convert your real data into machine or algorithm understandable way. For that, first need label the teams with numbers. Let us take RCB is 1 and CSK is 2. Then map the realm table with label table, the output of the numeric table or labeled table. That's it. You done the data processing. Moving to next. Machine learning model. A machine learning model is a program that can find patterns or make decisions from a previously unseen dataset. Let's input to model or algorithm is X, also X is training input. Input X is a 2-D array or list. Length of the list is number of inputs to model. Nested list is a input. Index 0 is team 1 or home ground team. Index 1 is team 2. Index 2 is year they played together. And let's Y be the model training output with 1D array or list. To create logistic regression, first need to import logistic regression from scikit-learn library. Then, create model object LR from class logistic regression with random state is equal to 0. After that, use fit function load trained data X and Y into logistic regression instance model. Logistic regression model is ready now for testing. Before that, check score, which is ideal should be 1. In our case is also 1, because we are using less data to fit model and optimal. Please note that less data we are using to train a model and model is not perfect model. All good. Let's predict the data RCB1, CSK2 and year 2026. Here is the predicted output 1 is RCB. Hacking key point is all home grounded team must win from this model. Try with more or complex data to get fine output. Hope this discussion finds understanding. And see you next.
Enjoy machine learning.